Hi, and welcome to Chapter 4. In Chapter 4, we're going to continue learning about objects by adding a little bit more detail to the stuff that we did in Chapter 3. Let's get started. We're going to go ahead and continue our conversation on blocks and scope. So I've mentioned this a few times. It's important enough to repeat multiple times. Understanding how blocks are defined and what scope means. So again, we have both outer and inner blocks. You can create a block for an individual class. That would be for everything in the class. Or you can have a block of individual code within a method. So the method itself, anything between curly braces, is going to be its own block. And you can create individual blocks within your code if you so desire. Inside of a block of code, your variables are going to come into scope. And when you leave that block of code, they are going to go out of scope. So recognizing the variable scope, where it comes in and where it goes out, is a really important part of recognizing programming. Any type of programming is going to have to deal with the scope issue. When are the variables available? When could you declare another variable with the same name and have them both exist simultaneously? And how that occurs. You can redeclare a variable. That is something that you are allowed to do. And when you do that, you set up a new value for that variable. The old one goes away. So remember, variable names need to be unique. So if you choose to redeclare your variable inside the same scope, you'll have some issues. If you redeclare the variable outside of the scope, so in a different scope, you should be fine. So in the example at the bottom, we have that the variable, some variable, is only in scope within its smaller set of curly braces. The second set of curly braces redeclares the variable, some variable, and sets it to a different value, which is fine because it's a completely different scope. It doesn't matter inside different scopes. However, the example given here of arbitrarily adding scope to a method is really bad coding. You don't want to ever do this. If you have a reason to have the variable used in two different places, go ahead and create another method and make that method scope for the first variable and then a second version for the second variable. But don't do this randomly curly braces. They're just doing this to show you how scope works, but this is really bad coding practice. Also recognizing with scope, if you declare a variable with the same name as a prior defined variable, so a global variable or a variable that is higher up in its scope, it will hide or override or shadow that variable. So if I declare a number at the top of my code over on the right-hand side, and then inside of my scope, I declare another a number, it will hide that number until it falls out of scope. Then the a number will go back to being whatever it was originally. So recognizing when variables are in scope and when they are out of scope is a really important part of any type of programming language. Our first You Do It is going to be a demo block on page 177. This is just going to be showing you how to recognize scope and to understand scope. So first we're going to go ahead and make our class declaration. And inside of our class declaration, we are going to add a statement that just says demonstrating block scope. So we're going to put that inside of our public void main. You should get pretty proficient at being able to write that. So we're just going to do a system out. And inside of it, we're going to say demonstrating block scope. Don't forget your semicolon. Inside of that, we're going to create our first variable, and it's going to be an integer. We're going to call it x. Usually, I would refrain from ever using x as a variable name just because it doesn't give you any information. But for the purposes of this assignment, that's fine. We're going to then print out in the first block, x is, and then we're going to put in our x. Colon, semicolon. Okay, so now when we run this, it'll say in the first block, the x is 1111, because that's what we set it to. I am then going to begin a new block. Again, as I said, this is bad coding practice. You don't generally want to do this, but that's okay. for the purposes of today, we are going to let us do bad coding practices just to show you scope. System out, println. And we're going to say in second block, X is, we're going to have X, and then we're going to have our Y. In the second block, Y is, and then whatever Y's value is. Okay, cool. So that was in our second block. Now we are going to make a third block. Again, really bad coding practice. This hurts. We're going to go ahead and declare Y again to be 3333. So we're going to go ahead and say in the third block. So I can come back up here and copy and paste. In the third block, X and Y. Now in this case, X is still 1111, but Y is now 3333. Okay. We are then going to call our demo method. So after in the third block, we are going to say demo method. We are going to build this demo method in just a second. Once we are done with demo method, we are going to recall after method, what are the values of X and Y? Okay, we have to go build our demo method, but before we do that, let's do our last at the end, what is X? Okay, so we've just done a couple of little scope things here. Where are different values? Let's go ahead and make that demo method. We're going to do a public static void demo method. It's going to go, cool, thank God you're finally writing that. What's wrong with you? And inside the demo method, we're going to ask the same question. So I'm going to come up here and we're going to do our system out. And we're going to say in demo method. And see the, and we're going to go ahead and set X and Y. So we're going to say int X equals 8888, comma, Y equals 9999, semicolon. So we can go ahead and declare those two variables inside of our demo method. So what you're going to find is that when we called our demo method, it's going to print out the demo method values and then go back to whatever they were ahead of time. So we're going to go ahead and compile this and run it. And what you're going to see, in the first block, we were at 1111. That's what we expected. In the second block, X is still 1111 and Y is 2222. Cool. We're going to then go into the third block and we get 1111, 3333, which we expected. Then we're going to call our demo method where we're going to have our 888 and 999. After the method, X is still 1111 and Y is still 3333 because the Y from here did not carry back up to here. These are two different Y's. They're two different variable Y's. And finally at the end, X is still 1111. Just a quick little demo of making sure you understand how the scope works. As I've said before, Java is an object-oriented language, which means it incorporates the phrase polymorphism, many forms, being able to have one method in multiple forms. We call it overloading. So you overload a method when you have the exact same method name, identifier, but different parameters. When we do our calculate interest method here, we have two different options. Our balance is a double, and that's fine. Both situations has the balance as a double. However, in one situation, we have the rate as a double, and one is where the rate is an integer. If I am going to give my rate, rates are generally a percentage, which means they can be referenced as a decimal. 0.03 would be 3%. 0.08 would be 8%. But it's a double because it's a decimal point number. If I give it to you as 0.08 or a double, I don't have to divide by 100. If I give it to you as an integer, 3, my percentage is 3, I have to divide it by 100 to get the percentage, to convert that rate to a percentage. What we've done here is we've actually created two methods with the exact same name that when you pass it the rate as a double, it knows that it's already in percentage decimal form, and we can go ahead and use it like that. If they pass it as an integer, the assumption being that a rate will never be more than 1, and obviously if you give me a rate of 3, that would be divided by 100, 300%, that wouldn't work right. So we need to take that rate and divide it by 100 to get 0.03 so that it works as interest. If you pass it as an integer, it'll get it. If you pass it as a double, it'll do the top equation. In English, we actually overload verbs all the time. So if I say open, well, that could refer to open the door, open the present, open the refrigerator, open your email. All of these are different examples of the word open that are not exactly the same thing. They may all mean to open, but they're different examples by context. The same way that we can overload methods by context, whatever your variables are, so your parameters. The important thing to recognize is in this that the return type is irrelevant. The point that's important here is what are the parameters and what order are they in. As I said, if we have parameters, we have to give them a data type. Your parameters in your method always have a data type. In the example given here, our simple method takes a double as its parameter. Java will be able to automatically promote to the higher type if you give it an int, or if you gave it a long or a float. It will go ahead and automatically automatically promote it to a double, so it'll run fine in the method. So I can take my example here of call simple method, and I can call it with a double and it works fine, and I can call it with an integer and it works fine, because Java knows how to automatically promote your types. It will automatically make that type a double because it can go up. That being said, don't try to pass a double in for an integer. It can't go the other direction. So it's very important to keep track of that. You can automatically type promote up, but you don't want to plan on it automatically type demoting down, because it won't do that. We're going to play around for a minute with a demo overload where we're going to talk about how to overload methods. This is going to allow us to use 3 methods, all with the same name, display date, and use 3 different possible parameters to explain it. Let's look at the code. On page 184, we are going to do another demo to show how overloaded methods are going to work. So we are going to have our demo overload class. Inside of that, let's go ahead and make our public static void main. I don't know why I keep hitting P. Args. Sorry, my hands are on the keyboard in the wrong spots, and when they do that, none of the keys hit correctly. I apologize. So first I'm going to go ahead and set 3 integer values. Month, and I'm going to set that to 6 because we're going to be in June. Day, we are going to have it as the 24th, and year, we are going to be in 2019. So this was last year. Okay, so our 3 integer variables. And I am going to call the method display date for each of them. As opposed to the way the book sets it up, I want to build each of those methods first, and then I will call them. So I will be coming back up here to put the display date. Display date methods stub. I like to put in comments when I know I need to come back and write some code. So I'm just going to say display date methods. I'm going to call it stub. I can actually do a search for stub if I ever find that there's any stub methods that I was supposed to put in there. So that lets me know there's something I'm going to be putting in there in a minute. Let's write our first display date. So public static void display date. Cool. Inside of our display date, we are going to pass a month. We're going to say int month. And we are going to have a print out, system out, println, and we're going to say event date plus our month plus, and we're just going to put in /1/2018. So this is going to come out of whichever month. Now we picked June up there, so it should come back and say, when we pass it, print out the date in 2016. So let's come back up here and just see how that goes. So we're going to do a display date, and we're going to pass month as our parameter. Let's run that real quick. It's kind of annoyed because I haven't written anything for those two methods, but that's okay. So when I run it, it's going to say event date 6/1/2018. Cool, that's just what I wanted. Let's build our next method. Public static void display date. And in this case, we are going to pass it an int month and an int day. So when I do this one, I'm going to do our system out, and we're going to have month, and we're going to put a slash, and we're going to put our day, and we're going to have a slash, and we're going to say 2018. Now, when this one gets called, it's going to print June 24th, 2018. But we're going to call it display date, and you'll see now that we have two choices here. You see that we have display date with month and display date with a day. And we're going to pick month, comma, and day. I'm going to pass both of those. We're still mad because we haven't used year yet, but that's fine. And as you can see, when we run, we get our first date of the 1st and our second date of the 24th. Finally, we're going to do our last one. Display date, and we're going to pass an int month, an int day, and an int year. And in my method here, instead of using a hard-coded 2018, I'm actually going to put in a slash and then continue it with year. When we call this method, I'm just going to move this down a little bit so you can see the whole code. I'm going to say display date. You can see now we have a third option, the one with the year, and I'm going to do month, day, and year. And you can see that it printed it out just what I expected with the year of 2019. By the way, when we talk about Java doc comments, we can include things in here that says what the parameters are. We have a parameter of month, and what is that? That is the month. We can say display date gives the event date as a printout, or something like this. When I put my mouse over the display date, you can see that it takes that text, display date gives the event as a printout. It also says what the parameters are, and it says refers to a month. So you can see how the text of that would be really, really useful. If I come down here and I do display date here, this is going to give me that Java doc comments, so I know exactly what my parameters are. You can do it, what's the return value? You can do a lot of different things. Just an example of the demo overload by using Java doc. At some point in your programming experience, you may have heard the phrase ambiguity or ambiguous. Ambiguity or ambiguous simply means the computer cannot figure out what to do. There is at least two options I can pick from, and I don't know which one you want. That's what the word ambiguity means. So there are multiple things that we can refer to as being ambiguous. What the computer doesn't know what to do, it usually will respond back with an error saying ambiguity or ambiguous method call. I don't know which method you want. Go make it more clear. Which method do you want me to do? The example that I have here is with a compute balance method. So the compute balance could pass in either a deposit or a withdrawal. However, both the deposit and the withdrawal are doubles. And there is no way for me to tell from compute balance 14.5 whether or not that's a deposit or a withdrawal. This is actually bad coding. You probably should say compute balance with deposit or compute balance with withdrawal, something like that. So this is just bad coding choice. But the idea of being able to have an overloaded method must have data types. If I wanted to overload the method compute balance, I need to have different versions of my data types for my parameters for it to make any sense. Because in this case, both data types are doubles. causing an ambiguity. If I wrote this code, Java would come back to me and it would say, ambiguous method call, which compute balance do you want? I don't know. The thing to remember with ambiguity, order matters. In the example here of the two truths and a lie, the first example is the one that is false. If you have my method with an int and then a string, and then create another my method with a string and then an int, that's okay. That's not ambiguous. However, if you have a my method with an int and a string, and you have a return value that's different, so in the second case, the return value is a string, and it still takes an int and a string, the return value is irrelevant. Those are still ambiguous because they have the same parameters in the same order. Obviously, even if they have the same return value, it is still ambiguous. Return type doesn't matter. What matters is the name of the method and the parameters and the parameter order. Those are what matters as far as ambiguity. So if you have two methods with the same parameter data types in the same order, you are going to come up with this ambiguity issue. So with our projects that we have done so far, talking about our objects and our classes, we've talked about constructors. We're going to now introduce constructors with parameters. I'm a big proponent of constructors with parameters. Why would I want to use getters and setters if I can just have parameters in my constructor and use them there? So we like that, being able to just have one line that says, I'm going to build a new employee and I'm going to give him his employee number at the time that I build him, and therefore it's going to be set. So the default constructor that Java will create automatically does not take any parameters. It just creates it and sets everything to null. The default constructor that we built doesn't take any parameters, but we can set a default value. So if you didn't give me a value, I'm going to set the employee number to 999. Okay, cool. But if I make a constructor with a parameter of an integer number, I can now set that employee number in one line and not have to write setters, which is convenient. We like to write less code if we can. So in this case, when I make a new employee, instead of saying new employee, open and close parenthesis, then the next line down, new emp dot set employee number, and then putting in the 999, we've combined those into one method call that says create a new employee with 523 as its parameter in the constructor. When we go into the constructor, we can build it as employee with its parameter and then go ahead and set that value. At this point, we're going to combine the overloading methods with the constructor, which is why we just brought up constructors right after overloading methods. You can have two constructors. One constructor doesn't take anything as a parameter, same one that you would do for your default. So an employee with an open and close parentheses, and it sets the default number. You can then have a second overloaded constructor that has a parameter of a number, and you can pass that in as well. Now we've created two constructors, overloaded, different parameters, so they work. And that way, depending on what the user wants, they can choose to either add nothing and get the default employee number, or to add a default or an employee number at that point. Overloading constructors is probably one of the most useful things that you're going to be doing in this chapter with overloading methods and adding parameters to your constructors. In this example, we are going to show overloading of constructors for our car insurance policy. Gotcha. Okay, and we're going to create our class for our car insurance policy. Our car insurance policy is going to take three private attributes. Private. We are going to have an int that's a policy number. We are going to have a private int that is number of payments. And we are going to have a private string resident city. Semicolon. Okay, let's go ahead and build our constructor. So we're going to make a public car insurance policy. It was kind enough to already know the name of the class, so it knew I was going to do that. And it's going to take three parameters. Num for number of payments, or for the policy number, int that's payments, and a string that is the city. You'll notice that all three of those were different than what the attribute was up here. When we do our car insurance policy, I'm going to say policy number equals num. Num payments equals payments. And resident city equals city. And I can use my constructor to set those three values. It's still a little mad because we've set the values, but we haven't actually printed them out or done anything useful with them. Let's go ahead and build a overloaded constructor that will give us a default city of Great Falls. Public car insurance policy. In this case, we're going to take in the policy number and the payments, but we are not going to pass in a city. So we're going to have our default be the city. In this case, we're going to go ahead and take these three things here, copy and paste. Be very careful when you copy and paste. You want to try to avoid it as much as possible, as we are going to explain in a few minutes when we do the this operator. We are then going to do a public car insurance policy that just takes the policy number. In this case, it's going to set the number of payments to a default value of 2. For some reason, we're only doing 2 payments in our car insurance, which is a little strange. Finally, we are going to do our printout or our display method. So public void display. This is a really common method, and I'm going to ask you to do it frequently in your code. You're going to have a display method, and the display method is going to print out nicely what it is you want it to do. So we're going to do a system out println, and inside here we are going to say policy number colon, and I'm going to add in my policy number plus period. Then I'm going to say the number of payments. Num payments plus payments annually. Oh, only 2 payments annually. That's what that means. Driver resides in resident city. And I'm going to add my period at the end because it makes everything look nice and pretty. So this is my display method, which means I can just call my display method on my object and it'll print this nice pretty thing out every time I need it. Cool. That's my class. My class is now built. Now I need to build my test file so that I can test it. In this case, it's going to be create policies.java. It'll go ahead and create my class for me. Here I'm going to do my public static void main string args. And we can get into our create policy. So here I'm going to make my first policy, which is a car insurance policy. First equals new car insurance. Thank you. And I'm going to pass it 123 as my policy number. That's all I'm passing it. Then I'm going to do car insurance policy second equals new car insurance policy. And I'm going to pass it my number 456 and the number of payments 4. Finally, I'm going to do my car insurance policy third, and it's going to be a new car insurance policy with 789. It's going to have 12 payments, and for some reason we are in Newcastle. Should say Bozeman. Okay, so that's first, second, and third. Now we're going to go ahead and display all 3. First display, second display, third display. Okay, so in this file, we have created our 3 using the different constructors that we had built over here. 1, 2, 3 constructors, 1, 2, 3 different ways that we're going to show it. Let's go ahead and run this code and see what it does. You can see policy 123 has 2 payments. That was the default. They're in Great Falls. Policy 456 has 4 payments because that's what we gave it, and they are also in Great Falls. And then the last one has 12 payments, and they're in Newcastle. So we were able to use the same constructor name, car insurance policy, in 3 different ways by overloading them. Now, just for kicks and grins, let's add in a 4th and see what happens if we don't add anything. And I believe this is actually going to give me an error. Yeah. So this has not used the default constructor. Did we forget to build a default constructor? No, we didn't. So because we are using constructors over here, it got rid of the default under Java's thing. So here we could do a default constructor, public car insurance policy with nothing, and include a 999 or something like that for our policy number. And that will allow us to run it here and be able to get our last one, 2 payments annually, residing in Great Falls with our policy number of 999. When we've written our methods inside of our class, I've asked you to go ahead and use a different variable name than the attribute for the class. In the example of a student, if we had an attribute called student number, I would ask you not to use student number as the parameter in your constructor, because we don't want the computer getting confused between setting the student number and the student number parameter that comes in. That being said, we can resolve that by using the this notation. This is an explicit reference to the class object itself. So think of it as, I am talking about this employee, John Doe, with an ID number of 123. Okay, cool. This object has a student number. This object has a GPA. This object has a name. Therefore, we refer to it as this dot, and then whatever the variable, the attribute type is that we're referring to. In this specific case, we can do this dot student number equals, and then whatever our parameter is. The parameter student number is going to override the student number that's local to the class. However, we can access that student number that belongs to the class by using the this notation. When you write your constructors, I tend to explicitly write this dot attribute for every one of my attributes, even if I don't have the same name in my parameters, just because I think it's clear. It's very explicit to be able to say this dot attribute, this dot student number, this dot GPA, and it makes it very clear to anybody who's looking at you that you are setting a local attribute for the object. You're not just playing with any variable. When you do that, if you get in the habit of that, even if you have the same name for your parameters, it isn't going to override it. You're going to be able to set the attribute correctly and move on, which is great. When you do that, you can do things just to be able to reference this object. You can reference it inside of any method, this dot student number as opposed to student number, or you can choose to do it by just saying student number, as long as there is no other local variable in your scope that would be overridden by that. Be careful. I've seen students who either pass variables or use variables inside of their methods, not realizing it's the exact same variable name as their class attribute. Then they try to reference their class attribute and can't figure out why the number doesn't come up correctly. So be careful. I love the use of this. I find explicitly writing things in code makes it so much clearer and makes it sure that you know exactly what you're talking about. This not only refers to the object itself in reference to this dot attributes, but you can also use this as a constructor. So if I have a class constructor, I can call this as though I were creating a new version of the class, but it refers to this constructor. In the example here, what we have done is we have overloaded our constructors, but instead of defining each of them individually, we are just passing in the default values that we want. So if I have a base constructor that says it's a student and it passes in both a student number and an average, so it's GPA. That's the first constructor. The second constructor, the one with the double, is where you're passing in an average without a student number. That means I want the student number to be 999 because that's my default for my student number. So I'm going to then call the original student constructor with 999 as my ID number and the average that I got from my parameter. It'll then move up to that top method and call that. My third constructor just passes a number. In this case, I'm going to use a default GPA of 0.0. Doesn't have any classes yet. He has his GPA of 0.0, but I know his number. So I'm going to call this number, the parameter that came in, and then 0.0, which is my default GPA. The final one is where you don't pass anything. This is the default student. I don't know his number. I don't know his GPA. So I'm going to pass 999 as his number, 0.0 is his GPA, and it goes back up to that original constructor that we built. Being able to use overloaded constructors makes your code so much cleaner because you don't have to repeat things. Now, in this case, you're only looking at 2 attributes. Imagine you were looking at 6 and having to repeat 6 attributes with default values each time. So much easier to be able to pass them as parameters to this constructor and be able to use the explicit constructor that takes both a number and an average. At this point, we are going to take our car insurance policy and make it better by using this. So we have created our constructor with our 3 values, our number, our payments, and our string. But for each of these, we are going to use this. So we are going to use this constructor, this parenthesis. And in this case, we have 2 other constructors we can pick from. We're going to pick the one that has everything filled out. We are going to pick our insurance number as num, because that's what was being passed in. Our payments are fine, and our city is going to be Great Falls, because that's going to be our default. We can get rid of that. Now we just have one line that's just going to call this method with those values. This one we are going to replace with this. We have the number, our payments are going to be 2, and our city is going to be Great Falls. In our default over here that we built, we are going to use this as well. And we are going to say 999 with 2 and our city of Great Falls. Now, the nice thing you may have noticed, I haven't changed any of this code over here. This is all still the same. We haven't changed any of that. So I can hit run on this code and everything will look exactly the same. It did everything perfectly the way we wanted, but each one of these overloaded constructors is literally one line now, which makes things happy and nice and clean. Being able to keep your constructors clean and your code useful. Now, if I were doing this for real, I would definitely be putting some comments. That I might put something over here saying integer policy number or something along those lines. I would definitely have comments all over my code if this was real. We're now going to talk about static fields. Some people probably think static and dynamic go together. Static and dynamic is not an unusual pairing between static and dynamic. Static being that it doesn't change, dynamic being that it does. Not really, not in Java. The word static is a field that is shared by all instances of the class. It is a singular field that can be modified that is shared by everybody. If I had an employee, I might set a static field of company name. I want everybody to have the same company name. And if I change the company name, I want every instance of that employee to change to now use the company name that I've now set it to. In the baseball example that we're using here, we are going to have a count of how many players are on the team. The count is going to increment every time we add another player. So if I create a player, I don't need to know how many players there were because we have a static count. So adding the first player, we now have a count of 1, where you can see in the constructor that it has count equals count plus 1. The second player we add is going to make that count equal to 2. If I ask any individual player what the count is now, everyone will say 2. Even the first player, who originally set it to 1, he now has the value of 2 as well. If I add a third player, the count is now 3. All 3 instances all have the value 3 because that's the value at this point. By the way, you can also see the show player method here, which is one of my favorite methods. I do this with almost every class I do, which is either a 2-string overload or I do a show something so that it does all the printing out in one cute little line and I don't have to write it. I can just say catcher, show player, outfielder, show player, and it'll print it all nicely. So you can see in your test player here, both with the example of the code and with the output, the increase in how many players were there when I showed them. So the first 2, 12 and 31, were added and they had 2 players at that point. Then we added the outfielder, and the catcher now say that they're 3 players because that static field is shared by all instances of the class. It is not specific to the instance. That would be if you had 5 houses all on the same street and you wanted them to share the street name that they're on. Each house is individual and they have the rest of their attributes are individual, but what street are they on? They all share the same street. They all share the same city. Something like that could be a static field for that group of houses. Now we go for what you may have thought static meant, which is constants. Constants are variables that cannot be changed. They have to be set once and cannot be changed after that. To make a constant, we use the keyword final. So the final keyword goes in there and you can say private static final integer and then whatever your variable is. We usually use all caps for constants. So for finals, we almost always use all caps just because it's a great visual when you're looking at somebody's code. If it's in all caps, it's probably a static or it's probably a final, it's probably a constant. In the example of the employee here, we have set a static final company string as company name, say my company. That means that you can't change company name. If I tried to write my employee, this employee, or this dot company name and try to set it, I can't. It's in the code. It's hard-coded in there when you create it. Non-static final keywords must be set in the constructor or in the class definition. So final, remember, constant final means that they can't be changed. They have to be set once and move on. If they are non-static, that means that they do not go along with everybody sharing the same value. Everybody has their own value, but you still might want to make it final a constant, such as their employee number. Their employee number shouldn't change. In theory, you set their employee once and you move on with your life. You would never change their employee number. Your date of birth generally doesn't change. We could make that a final as well. These are constant values that are set once. And you can see in the example here, we have set the employee ID inside of our constructor, in our employee constructor. Since it's in there, we can't do a setter for our employee ID. It's a final, it's a constant. You can't set it anyway. So there would be no set employee ID method in getters and setters because it's a final. You can't change it. Constants. So trying to keep track of static, meaning that it is shared among all instances of a class, versus final, which means it's a constant and cannot be changed. At this point, you're going to do a little project, and I'm going to walk you through the code of the dog triathlon. In this case, we are going to have a total cumulative score, which is the total score of all of the dogs in the triathlon. So it's going to be increased every time that you add a new score. So we know what the total cumulative is. That's going to be a static. It's going to be shared among all of the participants. The number of events that the animal is going to do is a final. It's a constant. You set it once when the dog signs up and you can't change it. So let's go look at that code. At this point, we're going to build our dog triathlon participant class. Dog triathlon participant, because we like those, with a Java. Okay, so we're going to make a class for our dog participant. In our dog triathlon, why our dogs are doing a triathlon, I don't know, but we are. So we're just going to go with it. We are going to add in a couple of static and final attributes. So first, I'm going to do my private final int num events. Remember how I said with finals, I like to put them all in caps. I'm then going to do a private static int total cumulative score. And we're going to set it equal to 0 to start with. Okay, so those are our first ones. Let's go ahead and then add our 6 regular private fields. Private string name, private int obedience score. Now we're going to go ahead and build our constructor. It's okay that there's a couple of things out of scope right now, like these are kind of mad at me. We're going to deal with those as things go along. So let's get in our first method before we go back and worry about those. So public dog triathlon participant, and he is going to pass a string name, a int num events, an int score 1, int score 2, int score 3. We're going to be able to calculate 2 of those scores as well. So those are all the things that are coming into my constructor. We're going to explicitly say the name is equal to the name. I like doing the this. This makes me happy. I do a lot of it. This, actually I can just do num events because it's final equals num events. Actually, it is not static, so I could do this. Yeah. And it's going to be set the first time. I can do this obedience score equals score 1. This confirmation equals score 2. This agility equals score 3. Okay. At this point, we need to calculate our scores. I'm actually going to look at this and figure out what's wrong with it. Oh, I didn't give it a type. Duh. Int. Apologize for that. Now we're going to build our total. Total is equal to obedience score plus confirmation score plus agility score divided by, actually total is all 3 of those scores. Cool. Average is a double. We are going to cast it to a double because some of these are ints and some of them aren't, and we want it to be in a double. So total divided by our num events. And our total cumulative score, which is our static up there at the top, is going to equal our current total cumulative score plus our total. So every time we add in somebody, we're going to keep doing this and we're going to keep playing with it. So far, we haven't used the name and we haven't used the average, but that's okay. We're going to fix that. We're going to write a display method. Again, you are going to write lots of display methods. Void display. And our display method is going to say system out println name plus participated in plus num events plus events and has an average score of average. We're then going to say system out println name plus has a total score of, we're not total, plus bringing the total cumulative score to total cumulative. So every time you print this out, it's going to print those 2 lines. Cool. Let's go write some code to test it. So we're going to write test dogs.java. going to grab that and just put it over there so that we can see both of our lines of code at the same time. And I'm going to write my public static void main string args. Okay, first thing we're going to do is make a dog triathlon participant dog1. And he is going to equal a new dog participant. I'm actually going to grab him and put him over here just because I want to be able to see more lines. Okay, his name is going to be Bowser. He is going to be in 2 events, and his scores are going to be 85, 89, and 0. Apparently he bombed the last one. Poor dog. He probably just had to go to the bathroom or something. Poor thing. Okay, we're going to go ahead and make dog 2. Dog triathlon dog 2. He's going to equal a new dog triathlon participant. Sorry. There we go. His name is going to be Rush. He is going to be in 3 events, and he is going to be 78, 72, and 80. Dog triathlon participant, dog 3 equals, oh, that 0 for Bowser is because he only did 2 of the 3 events, I see. Ginger, whoops, new dog triathlon, and her name is Ginger. She is in 3 events, and she got a 90, an 86, and a 72. Cool. After each dog, I'm going to go ahead and call dog display so we can keep track of our running total. So dog 1 display, dog 2 display, and dog 3 display. All right, let's go ahead and run that and see what happens. And you can see here, Bowser participated in 2 events with an average score of 87, 85 plus 89 divided by 2, and the cumulative score was 174. Rush participated in 3 events, and his average score was this obnoxious decimal here, but it was 76 and changed in 2/3. And our cumulative is up to 4.4. And Ginger got an average of 82, which brings the total up to this. So you can see how using the constructors, using the scores and being able to build, and then doing your display. This just gave you the version of the constants that changed. We set the number of events inside of our constructor because you can't touch them anywhere else. I didn't have to add any setters or getters. And our total cumulative score increased over time. Every time we added a new dog, a new participant, it increased that score. Some libraries are already automatically imported, such as the math library. The math library gets automatically imported because it is used so much. In the example over on the right-hand side, you'll see some of the methods that are available in the math library. It also includes things like pi and e and some constants like that that are useful. You don't have to specify java.language.math.pi to be able to reference things in the math class or in the math library. Those are already automatically imported. However, there are some that are not automatically imported. If you want to import non-automatically imported classes, you have to use the import method or the import keyword. The import keyword just says import and then whatever the class name is. You've done this actually with your scanner, whether you know it or not. When you use your scanner, you have to import the scanner class, the scanner library, because if you don't, it doesn't know where the scanner is. Now remember, the Java utility is the name of the library, and the scanner in this case is the class. Remember how I said that I always capitalize my class names? Anything that's capitalized here, you can see those are going to be your class names. The lowercase, Java utility, Java swing, Java time, those are going to be your libraries. You can import all of the classes in a given library using a wildcard character. So if I use java.time.star, I can import all of those classes, even though I may only use one or two of them. When you import, you want to use your entire path with your class name if you want to import the entire class. If you want to import the entire package that contains the class you're using, you need to have the package name with a star to include all of that. You can, technically, use the full path without an import. So I could say java.utility.scanner in equals new java.utility.scanner, taking a system in. But why would you? That's just extra text and it's irritating. So again, you can. If you just have a one-time thing where you're just using this class one time and you really don't care, or you want to be explicit about it in your code, you can reference it directly, or you can just put import at the top of your page. We've been talking about how classes need to be in a file with the class name. Technically, that's true. However, you can nest classes. So in the first example, composition of classes, each class has its own file. So we have name and address in a file, and we have school in a file, and school uses the name and address type to refer to its name and address, and it's used in there, and that's fabulous. So we can do it in their own file, and that's fine if you like having multiple files and keeping it like that. If you do not feel like you are going to use the inner class anywhere else except within the class that you have, you can do it as a subclass. So in this case, on the right, we have a nested class. We've created a real estate listing, and then inside of our real estate listing, we have built a class inside of it called house data. The house data class gets built just like any other class with its attributes and its constructors and its methods, all inside of curly braces to keep its scope. That class is a subclass now of your real estate listing class and can be used inside of your real estate listing class just like any other variable. So I can say private house data house, and that's going to reference the class that is nested or subclassed inside of my real estate listing class. So being able to nest your classes sometimes is an easy way to keep things straight and organized without having to have 5 or 6 files. If you want to have just a small little class, it's only going to hold like 3 attributes. I don't even really need to make the attributes private. I can make them all public, and I'm just going to throw in 2 constructors and move on with my life. Maybe 1 little method. It's a really small class. There's not much to it, but I want it to only be used within my current class. I can make a subclass and put it all in there. Saves you from having to write an entirely different file, compile the file, and run it alongside. So nesting classes is kind of fun. Hopefully this gave you a lot of different advantages to using classes and things that you could do to make your code better. Again, constructors, overloading your constructors, multiple constructors for different attributes. Don't forget, don't use your variables out of scope. Know what the scope is. At any point in time, I should be able to ask you, what is the scope of this variable? And you should recognize it. So scope is one of those words we're going to say frequently. Don't assume that a variable is constant. So if you are expecting a variable to be constant, make it final, make it constant. And that way you will be notified anytime you accidentally try to change it. If you don't set the final keyword and you do change it, nobody's going to tell you. The code's not going to remind you, hey, that was a final keyword, or that was a final variable. You weren't supposed to change it. It'll just go on. And so you're making the assumption that it's a constant when it's not. Always define your constants with the final keyword so that you know if you want to try to change that. When you overload, change your parameter data types, not your return type. The return type is irrelevant, doesn't matter. What matters is the parameter types. Essentially, just telling me what the resulting value of a method is isn't enough to tell the compiler what to do. The compiler is not going to go backwards and go from the resulting value, what am I assigning it to, and then go that way. No, it is looking for the parameter types. That's all it's looking at. And obviously the name of the method. Don't assume that the default constructor is the automatically provided constructor. You can choose to make your own constructor with no parameters to replace the default constructor. So yes, you could probably use the default constructor that comes automatically that Java will use every time you create a class, but it's better for you to build your own Can I call you right back? I'm almost done with this video. Okay, bye. You can always make your own constructor with no parameters just to make sure that it's explicit and you know what's going on in it. I tend to say plan on always building your default constructor. Overload your constructors, make your life easier. That just works. So don't, just because Java's compiler will do it for you, doesn't mean you should. You can do this on your own. You'll be fine. I hope this chapter on more objects gave you a little bit more detail into how to write your code in Java. Please make sure you reference the assignments and ask any questions. If you have questions about this video, feel free to post them in the comments or send me a chat, and we will come back next time with Chapter 5. Thanks so much for watching.